Today we'll start with electricity part 2. The first topic we are going to discuss is the concept of resistance. That is, what is resistance? The concept of resistance. So when a current flows through a conductor, this is a conductor, and when current flows through a conductor, say this is a metallic wire. I am taking an example of a metallic wire. This wire, it offers obstruction to the flow of current. That is, it offers some resistance. So what is resistance? Resistance is nothing but the obstruction offered to obstruction to the flow of current. Obstruction offered to the flow of current by the conductor, and in this case by the metallic wire and by the conductor. That is known as resistance. This is called resistance. Now let's understand what is the cause of this resistance. So we know this is a metal. We have taken a metal wire, and we know that metal has large number of electrons. They have large number of electrons, and they also have equal number of positive ions. They have electrons and also have equal number of positive ions. What are these positive ions? The atoms which have given out the electrons, which loses the electron, they form the positive ion. The positive ion, they do not move, but the electrons, they are free inside the metal to move. So suppose this is a positive ion present within the metal, and the electrons, the negative charge, they are freely moving, they are randomly moving and colliding. They move at random motion, and they collide among themselves and with the positive ion in this manner. But what happens when the end of the metallic wire, suppose the end of the metallic wire, it is connected by a cell or a battery. We have taken the example of the metallic wire. This is a metallic wire, and it is connected to a cell or battery. It is connected to a cell or battery. Okay, what happens in that case? When it is connected, it is connected to a cell, means a potential difference is applied across the end of the metallic wire. The electron inside it, they start moving from the negative end to the positive end. The negative end to the positive end. In this direction, electrons flow. And in the meantime, they also collide with the positive ion. The electrons, when the end of the metallic wire, it is connected to a cell or a battery, that is a source of current, which means I am giving a potential difference. A potential difference is applied across the end of the metallic wire. The electrons inside it, they start moving from the end which is at negative terminal. This is at negative terminal, this is at positive terminal. We know electrons flow from negative end to the positive end, and current flows from positive side to the positive terminal of the battery to the negative terminal. Okay, so during the flow of the electron, their speed decreases. Why the speed decreases? But during the movement, when they collide with the positive ion, they lose some of their kinetic energy, and that is the reason why the speed, it decreases. The speed of the electron decreases because they are colliding with the positive ion. When the potential difference is applied across the end of the metallic wire, the electron starts in the first case, the electrons were moving randomly, but here the electrons are moving in an organized manner from the negative terminal of the battery to the positive terminal of the battery, while the current is flowing from the positive to the negative terminal. So during this case, what happens is, after the collision, when the electron will start moving after the collision, the speed decreases, and this process it continues, as a result of which the electrons that uh, there is a drift. They do not move in bulk with a continuous increasing speed. They do not move with a continuous increasing speed because they are continuously getting collided with the positive ion. So what happens? There is a drift of electrons towards the positive terminal from the negative terminal, and thus a metal wire offers some resistance to the flow of electrons through it. So this is the cause of resistance in a metallic wire. The resistance of a conductor, it depends upon the number of collisions suffered by the electron, the number of collisions suffered by the electron with the positive ion. That from while they are moving from one end to another, the number of collisions they suffered by the number of collisions suffered by the electrons with the positive ion. That is the cause of the resistance. Now comes to the next point. What is Ohm's law? What is Ohm's law? So according to Ohm's law, the current we denote it as I, the current flowing in a conductor, it is directly proportional to the potential difference. Potential difference we denote it with capital V. Potential difference which is applied across the end of the conductor, provided that the temperature remain constant. This is the Ohm's law, that is the current flowing in a conductor, it is directly proportional to the potential difference which is applied across the end of the conductor, and provided that the temperature of the conductor it remain constant. Okay, so if a current I it flows in a conductor when potential difference across its end is V, then according to Ohm's law, I, that is the current, is proportional to it is V, or we can write that V by I is equal to constant. By just removing the proportionality sign, we come that V by I is equal to constant. Now if we put this constant equal to R, if we put the constant is equal to R, what is R stands for? R stands for the resistance of the conductor. Constant is equal to R, then the formula comes to V by I is equal to R, which is also equal to V is equal to IR. V is equal to IR. Okay. Here R is a resistance which is constant. R is a constant, and at a given temperature, the resistance offered is constant for a given conductor. This is very, very important, that the resistance R is constant at a given temperature for the given conductor. So V is equal to IR. Now let's come to the unit of resistance. What is the unit of R? What is the unit of R? We know V is equal to IR. So R is equal to V by I. We write V, and in the unit of potential difference is volts, and unit of current is ampere. So volt ampere inverse, volt ampere inverse, or which is later on named on the scientist Ohm. So the unit of resistance is Ohm, which is written as this, Ohm. This is the sign of Ohm. So this is the unit of resistance. So what do you mean by 1 ohm? What do you mean by 1 ohm? How can you define 1 ohm? 1 ohm is the resistance of a conductor. A resistance of a conductor is said to be 1 ohm if 1 ampere current it flows through it. 1 ampere current, 1 ampere flows through it when a potential difference of 1 volt is applied. When a potential difference of 1 volt is applied. Mathematically we can write 1 ohm is equal to 1 volt by 1 ampere. Now come to the high resistance. How high resistance are measured? For example, if I take example of kilo ohm, 1 kilo ohm, 1 kilo ohm is equal to 10 to the power of 3 ohm. 1 kilo ohm is equal to 10 to the power of 3 ohm. Then comes to 1 mega ohm, 1 mega ohm. 1 mega ohm is equal to 10 to the power of 6 ohm. 1 mega ohm is equal to 10 to the power of 6 ohm. So this is the high resistance. This is how high resistance are measured in units. That is kilo ohm and mega ohm. Now what is conductance? What is the meaning of conductance? What is the meaning of conductance? Conductance is nothing but the reciprocal of resistance. 1 by resistance is conductance. 1 by resistance, that is 1 by R, is conductance. What will be the unit of conductance? 1 by ohm, or we can write ohm inverse. This is the unit of conductance. Now come to the IV graph. For a metallic conductor, the ratio of V by I is constant. For a metallic conductor, V by I is constant for all values of V and I. So if we plot a graph, in the y-axis we will write I, that is current, and in the x-axis voltage. So how will be the graph? The graph will be a straight line passing through the origin. This is the IV graph. For a metallic conductor, the ratio of V by I is equal to constant. We know that V by I is constant for all values of V and I. So if a graph is plotted for the current, we are taking it in y-axis and voltage in x-axis, we get a straight line which is passing through the origin. Now what gives the slope of the IV graph? The slope of the IV graph, this is the slope. The slope of the IV graph. The slope of the IV graph is delta I by delta V, which is the reciprocal of resistance 1 by R. This is the slope of the IV graph. The slope of the IV graph is delta I by delta V, which is the reciprocal of resistance of the conductor. That is, slope is equal to delta I divided by delta V is equal to 1 by R. 1 by R means 1 by resistance of the conductor. Now come to the limitation of the Ohm's law. If a question asks, what is the limitation? What is the limitation of Ohm's law? Ohm's law has a limitation, and what is that limitation? That Ohm's law is obeyed only when the temperature of the conductor, only when the temperature of conductor is constant. Only when the temperature of the conductor it remains constant. This Ohm's law is obeyed only in that case. So this is the limitation of Ohm's law. Next, come to the point about let's talk about the VI graph. I have talked about the IV graph. Now let's talk about the VI graph. What happens in this VI graph? So a graph is plotted for V against I. So V is taken in y-axis and I, that is current, in the x-axis. This is V by I graph. A graph is plotted for V against I by taking V on the y-axis and I, that is a current, on the x-axis. And that is also found to be a straight line straight line passing through the origin. And what does the slope of the VI graph gives us? The slope of the VI graph, slope is equal to delta V by delta I, which is equal to resistance R. The slope of V versus I graph, it offers resistance. The slope of V versus I graph, it gives resistance. So one thing is clear: greater the slope, greater the slope greater the slope of VI graph, greater the slope of VI graph, greater will be the resistance. Greater is the resistance. Greater is the resistance. So greater the slope of VI graph, V by I graph, the more the slope of the VI graph, the more will be the resistance offered. The more the slope of the VI graph, the more will be the resistance offered. So the slope of delta V by delta I, it gives us the resistance of the conductor. So greater the slope of the VI graph, greater is the resistance of the conductor. This is very important. So that's all for today. In our next class, we shall start with the factors affecting the resistance of a conductor.